So let us see this one again. Here what we are doing is we have an IP address over here of router 1 and router 2. Here what we will do is these both will have IP addresses 1.1.1.1 and this will have an IP address of 2.2.2.2. They should ping. Why? Because we are using serial cables, but the encapsulation is not going to allow us. As of now, if I say configure terminal interface serial 2/1 IP address 1.1.1.1 255.255.255.0 no shut. Similarly on interface serial 2/1 IP address 2.2.2.2 255.255.255.0 no shut. Now if I say show CDP neighbor detail, he will tell me the detail of my neighbors. It's a layer 2 protocol. It should work 2/1. Yeah, 2/1. Okay, maybe because CDP is not running on your serial interfaces. Now I can say show IP route. As of now, I don't have any route how to reach my neighbor, right? Can I say ping 1.1.1.1? This should not allow us to do that. But what we will do is, let us see, show interface serial 2/1. In here, by default, the encapsulation is high level data link control, HDLC. HDLC, you can say, is Cisco proprietary, but every vendor has its own HDLC implementation. So there are open standards also. Now, if I want to do something, now sometimes there is a thing that if two devices do not have the same encapsulation, the link does not come up. So if I say, now do show IP interface brief, here my links are up on layer 1 and layer 2, my link is up, right? But if I say interface serial 2/1, encapsulation PPP. PPP is point-to-point protocol. In your home environment, you run PPP OE, point-to-point protocol over Ethernet. And here we are running point-to-point protocol over serial link. So in here, I will say, see if I gave him PPP encapsulation, the link went down. The layer 2 status will go down because the encapsulation is different on both the sides. So if you are troubleshooting and you think that I gave everything no shut, everything is fine, maybe the encapsulation is different on both the sides. Okay, so let's go on the other side. Interface serial 2/1, encapsulation point-to-point protocol. Okay, now if I say, see, earlier the link went down, now the link comes up. Why? Because the protocol is same on both the sides. So if I checked over here previously, it was down. If I check now, it should be up. Better than before, because now the encapsulation is matching. And one more thing with PPP, if I say I checked the routing table previously, right? I saw on router 2, I saw show IP route, and it did not show me any route related to 1111. Once you do point-to-point protocol, this PPP will automatically give you a directly connected route. See, PPP. So the rule that we were seeing is for two devices to communicate, they must be in the same LAN segment, right? Here, both the devices have same or different IP addresses. I have 2222, he has 1111. But because point-to-point gave us a link, a route directly connected, so that is the reason we can ping. Earlier we saw one guy had 1111 and other guy had 2222. Over here I have two routers connected like this, and if I say this is 1.1.1.1, and on the other side if I say I have 2.2.2.2, this is not allowed to ping. But if you are using point-to-point protocol, it is allowed to ping. Now you are using serial connectivity, you are not using gigabits, you are using your serial connections. So serial connectivity is of different type. We are changing the encapsulation to point-to-point protocol. Now, what is the benefit of point-to-point protocol? Point-to-point protocol will allow you to authenticate your neighbor on your layer 2 links. So before the link comes up, kindly check whether he gives you a password. So what we will say is PPP. Now in your point-to-point protocol, there will be one person who is the authenticator and who is the person who provides the authentication. For example, I will say encapsulation PPP. I will say encapsulation PPP and PPP authentication PAP. There are two authentication methods. One is PAP and one is CHAP. CHAP. There are others also, MS CHAP, Microsoft CHAP and all. But here we will use PAP first. Point-to-point protocol. This is password authentication protocol. Now this is a very simple protocol because it checks the link when it comes up. Later on, no, nothing. First, if you want to on the link, you should give me your password. So you have to create a username R1 and password ABC, for example. This is the guy. This is the guy who is the authenticator. He will authenticate him. He should provide the credentials. Router 1 should provide the credentials and router 2 should authenticate him. You can do it two ways also. You can say, okay, give me a code, and he will also give you a code. So both will authenticate each other. But we are not doing that. We are doing R2 is the authenticator. He is the bank and I am the person who wants to operate my account. Simple as that. So encapsulation is done. Let us say PPP authentication PAP, and this will be done under the serial interface, under the physical interface. Let us go on router 2 and let us say configure terminal interface serial 2/1 PPP authentication question mark. See, there is password authentication protocol, challenged handshake authentication protocol, Microsoft challenge and all. So PPP authentication PAP. The moment I say PPP authentication PAP, the link goes down. Why? Because R2 wants him to provide with a password, username and password, and he should have a username and password created also. So I will go back on R2 and I will say exit, username R1, password ABC. Simple as that. So for you to provide the authentication, I need some username and password, and this is local authentication. You can also use Radius, Tuckax and all other servers also. Now the link is going down. Now in here you can say debug PPP question mark authentication. Now he will tell us that authentication is required, and what I will do is I will go on the and debug PPP PPP authentication PPP packet, if you want to say. So I want to see what is inside the PPP packet. See, this is going on in the backend. What I'll do is I will say you all. That is the reason we do not run debugs. It will flush it off. So what I'll do is I'll simply go on other side, interface serial 2/1, shut this one down. Once the link is down, he should stop doing that. It's happening a lot. Let's wait for a second. That is the reason I always tell my people, do not run debugs on the first day itself. Now, what we will do here is, oh, no worries, let it run, no problem. I'll go on router 1 and on the serial interface, I will specify the username. I will say PPP PAP sent username. Router 1, password ABC. What am I doing? I am sending the PPP username, and so I am sending the username on this link of mine. So he sends the username to router 2. He compares with the sent username into his database. The moment the comparison is successful, the link should come up. Let's see, has router 2 stopped? Yeah, thank you for stopping it. Now I will turn on the link, no shut. And here the link should come up automatically. See, change state to up. Now what I will do is I will enable captures. Let us see. People are not going to use PPP. Why? Because it authenticates only in the first time, and the password is going to be sent in a clear text format. So anybody seeing the packet, anybody analyzing, he can simply see the password of that guy. Let us see. So what I will do is I'll simply go on my router 1 and I will shut down the link. As of now, there is no authentication going on. The moment I go over here on router 2 or router 1, any interface, see any routers, shut it down, no shut. So if I say shutdown and no shutdown, the authentication will happen. And in the back end, we will grab these packets. So configuration, see, password is ABC. You can clearly make out peer ID is router 1, password is ABC. So it is not very much used, you can say, because it sends the username and the password actually in a clear text format. If I even if I open this one in my authentication PAP, it should tell me the password length 3 and PPP point-to-point protocol. There will be a field wherein you will be able to detect, see, password, peer ID is router 1, password is ABC, clear text format. That is why we are not going to use point-to-point protocol. And one more thing about PPP is, now if I go and change the password on router 1, he has already sent his password. He has already been authenticated. So the link will not go down. That is why we will use something called CHAP. Instead of PAP, we will use CHAP. Nothing much. So here you can say interface serial 2/1, no PPP, authentication, PAP, PPP, authentication, CHAP. Right? And on the router 1, I will say no PPP. And in here, PPP question mark. PPP CHAP should be there, but there is something other. Yeah, PPP CHAP hostname, or you can say hostname will be this one. Password is ABC. Let us check. Show IP interface brief. Do show IP interface brief. This link is up. I will flap this link up. Shut down and no, shut this link down. Let us say whether the authentication happens. Link is up, link is up. Right? So the thing is, it is very similar to PAP, but here you say PPP authentication CHAP. It is very easy. You can say, let us start Wireshark. Let us capture it again. So in here, if I change the username or password, it will not allow us to bring the link up. In here, it is doing this one. So I'll just flap the link again. Shut this one down. No, shut this one. Shut, no shut. Let us see some packets. Device ID echo request challenge. See the value. It's now encrypted. So instead of sending the password, here see it says message is success. Now they will raise a challenge and they will authenticate each other. So challenge and the response. He will raise a challenge and the other guy will give the answer to that challenge. Password is not sent on the wire here.